Lesson 23. I will use division and the associative property to test for factors and observe patterns. You did all of these already when you did your Zern lesson, but I know that there were some of the strategies that we were using were a little bit confusing, so we're going to talk about those a little bit more in our problem set today. All right, so let's take a look at our problem set. Go ahead and write your name at the top of your paper, and let's look at the direction. Explain your thinking or use division to answer the following. So, first of all, let me say that you can always use division to test for a factor. Anytime you are unsure how to find a factor, you can always divide. And the rule is if there is a remainder left over, then it's not a factor. So let's use division on this one, even though there is a pattern that we can use. Let's go ahead and divide this one and see what we get. So I'm going to pause the video. I want you to finish this division, and we're looking to see if we're left with a remainder. Okay, so hopefully you finished your division problem. When I finished my division problem, I found that 84 divided by 2 was 42, and there was no remainder. So is 2 a factor of 84? And the answer is yes. Now, if I didn't use this division problem, I could explain my thinking, because 2 is one of those numbers that tells me when I divide something by 2, that means I'm going to put it into 2 equal groups. Well, because 84 is an even number, and I know this because the 4 in the ones place is even, that tells me that I should be able to evenly divide this number into 2 groups. That's what it means to be even. Any number that can be put into 2 groups with no remainder is an even number. Therefore, any even number can be divided by 2 without a remainder. So when I look at B, I could go ahead and divide 83 by 2 and see that I have a remainder, but because again I'm dividing by 2. Well, if you look at 83, 83 is not an even number. The 3 tells me that it is odd. So what makes a number odd is when you put it into 2 equal groups, there's always an odd one left over, which means that there will be a remainder. So is 2 a factor of 83? And the answer is no, because I'm going to go ahead and explain because I'm not using a division sentence. No, because 83 is odd. Okay, let's take a look at number 3. All right, so is 3 a factor of 84? So I don't know a trick to 3, so I'm going to have to go ahead and use division. I want you to go ahead and use long division, take 84 and divide it by 3, and let's see if we're left with a remainder. Okay, so while I paused the video, I went ahead and solved this division problem. I went ahead to see if there was a remainder when I took 84 and divided it by 3, and it ended up with 28 with no remainder. So is 3 a factor of 84? The answer is yes. I want you to take a look at D and see if you can answer this one all by yourself. See if you can use what you've learned to answer this one. Okay, so what did you decide? Is 2 a factor of 92? Well, yes, it is. Now, there's 2 ways you could have answered that. You could have divided 92 by 2 and shown that you had no remainder, or you could have just said that it is a factor because 92 is even. And remember, that's what makes a number even. You can divide it into 2 groups with none left over. All right, let's take a look at E. So, we have E, F, G, and H. Now, I'd like for you to go ahead and do E and F by yourself, and if you feel confident, go ahead and do G and H. Remember, you can always divide, always. Sometimes there's a faster way to do it by looking for a pattern, but using division to see if you have a remainder will always get you the answer. Okay, so let's see what you came up with. So did you decide, is 6 a factor of 84? Well, I chose to divide because I couldn't think of any pattern, and when I divided 84 by 6, I did not get a remainder, so I said that yes, 6 is a factor of 84. All right, so what about number 4, or F, excuse me, is 4 a factor of 92? Again, I decided to use division, so I took 92 and I divided it by 4, and when I did this, I did not get a remainder, so again, yes, 4 is a factor of 92. All right, so what about G? Well, you could have used division here. You could have divided 84 by 5, but I knew that all numbers that have 5 as a factor end in 0 and 5, because when you count by 5s, they all end in 0 and 5. So I knew right away that 84 was not or that 5 was not a factor of 84 because 84 does not end in a 5 or a 0. If you use division here and you got a remainder, you still would have got the answer no. All right, so for H, when I was looking to see if 8 was a factor of 92, again, I decided to use division. And when I divided 92 by 8, I got a remainder of 4. So no, 8 is not a factor of 92. So we've used all on this front page the strategy of mostly we use division. We did learn that all even numbers have a factor of 2 and no odd numbers have a factor of 2. And we know that any number that has a factor of 5 ends in a 5 or 0. But for the rest of them, we just divide it. And you can always use that strategy. On the back, we're going to talk about another strategy, which is a little bit easier if you understand it. But remember, you can always use division if the other strategies don't make sense. All right, so we're going to talk about the associative property. So the associative property here tells us that it doesn't matter which numbers you multiply first whenever you break a number apart. So if I have 3 numbers in a row and I multiply them, so let's just take a little mini break here for a minute and talk about the associative property. So let's just talk about if I had the numbers 4 times 3 times 2. So the associative property says if I multiply 4 times 3 first, I should still get the same answer as if I had 4 times 3 times 2, and I decided to multiply 3 times 2 first. So let's test this. So 4 times 3 is 12, and then I have 12 times 2. So what is 12 doubled? What's 24, right? So when I come over here, this time I'm going to do 3 times 2 first. So that gives me 4 times 6. Well, what is 4 times 6? It's 24. So it does work. It doesn't matter if you multiply the first 2 numbers first or if you multiply the last 2 numbers first, you still get the same answer. So we can use this property to help us define whether or not a number is a factor of another number. So let's talk about how we can do that. So let's go back here, and first of all, you're going to see there are only 2 factors. So we can't use the associative property the way this is written. So we're going to decompose 12, and they've already decomposed it partly for you. They said, okay, 12 is the same as something times 3. So what times 3 equals 12? Well, hopefully you said 4. So they're saying, well, it doesn't matter if I do 4 times 3 first, which gives me 12, or instead of doing 4 times 3 first, let's move the parentheses and do 3 times 2 first. So this is still 4. It's still 4 times 3 times 2. 4 times 3 times 2. It's just now they wanted to multiply the 3 times 2 first. So this is still 4. So we've got 4 times 6 instead of 12 times 2, which gives us 24. So what this says is 12 times 2 is a factor of 24, but so is 4 and 6. All right, let's try this again with 36. All right, so we've got something times 4 equals 36. So think about your multiplication facts. Hopefully you remember that 9 times 4 is 36. So they decompose 9. So what times 3 equals 9? 3 times 3, right? So if we went ahead and multiplied 3 times 3 again, we would still end up with 9 times 4. Well, we already know 9 and 4 are factors of 36. We're trying to figure out what else are factors of 36. So instead of doing 3 times 3 first, we're going to do 3 times 4 first. So the 3 is still here. It's still 3 times 3 times 4. 3 times 3 times 4. Just now we're going to multiply 3 times 4 first. So now it's 3 times 12. And 3 times 12 is 36. So we know that 9 and 4 are factors of 36, and so are 3 and 12. Again, if this is confusing to you, that's okay. It's good to stretch your brain to learn something new. But remember, you can always divide to see if a number is a factor. All right, so it says in class we use the associative property, but you can think of this on Zern. We use the associative property to show that 6 is a factor and then 2 and 3 are factors, because 6 equals 2 times 3. So we're going to use the fact 8 equals 4 times 2 to show that 2 and 4 are factors of 56, 72, and 80. Okay, so we're going to decompose the 8 in every one of these facts into 4 times 2. So let's do this together. So instead of saying 56 equals 8 times 7, we're going to decompose the 8 and say 56 equals 4 times 2 times 7. Okay, we're going to do the same thing here. So instead of saying 72 equals 8 times 9, we're going to decompose the 8 and say 72 equals 4 times 2 times 9. And same thing with 80. Instead of saying 80 equals 8 times 10, we're going to decompose that 8 into 4 times 2 times 10. Okay, so now we're going to use the associative property. So remember, the associative property says as long as we're multiplying 4 times 2 times 7, it doesn't matter if I multiply 4 times 2 first, I can multiply 2 times 7 first. And what this does is this shows me another factor of 56. Okay, so I've got 4. Now I'm going to go ahead and multiply 2 times 7, which is 14. So now 4 times 14 does equal 56. So I know that not only 8 and 7 are factors of 56, I know 4 and 14 are factors too. Let's try this one, and then I'm going to let you do the last one by yourself. If you are understanding and you want to go ahead and do this one by yourself too, go ahead. But I'm going to go ahead and walk you through this one if you need me to. All right, so 72. So remember, as long as we're multiplying 4 times 2 times 9, instead of multiplying 4 times 2 first to get 8, I'm going to do 2 times 9 first. So that gives me 72 equals 4 times 18. So now I know 8 and 9 are factors of 72, and so are 4 and 18. I want you to try to do this one all by yourself. The worst thing that happens is you get stuck and you have to press play, but I want you to try to do it as much of it by yourself as you can. Okay, so instead of multiplying 4 times 2 first, I went ahead and rewrote that as 4 times 2 times 10, but using the associative property, I'm multiplying 2 times 10 first. So 4 times 2 times 10 is the same thing as 4 times 20. Therefore, I know that 8 and 10 are factors of 80, and so are 4 and 20. So remember, if you wanted to know if 4 was a factor of 56, you could use the associative property. You could say to yourself, well, I know 8 times 7 is 56, and I know 4 times 2 is 8, so yes, it is. Or you could use division. Remember, you can always use that strategy. All right, so let's take a look at number 4. The first statement is false. The second statement is true. Explain why using words, pictures, or numbers. So it says if a number has 2 and 4 as factors, then it has 8 as a factor. If a number has 8 as a factor, then both 2 and 4 are factors. So it says that this is false, and it tells us that this is true, and we're trying to prove that the second statement is true. So how can we prove that if a number has 8 as a factor, then both 2 and 4 are factors? Well, how do you prove that a number has 8 as a factor? Well, you could show it using division, right? Do you know any number that definitely has 8 as a factor? All you have to think of is anything times 8 is going to have 8 as a factor. So what if we did 8 times 32, or 8 times 4? 8 times 4 is 32. So that means that 32 has 8 as a factor, because when I multiply 8 times 4, it gives me 32. So we know that this number has 8 as a factor. How can we prove whether or not 32 has a factor of 2 and a factor of 4? Well, we could use the associative property, or we could use division. I'm going to pause the video, and I want you to choose either divide to prove that 2 and 4 are factors, or you can use the associative property. So you get to decide. I'm going to solve this problem both ways so that I can show you the answer to either one, but you decide which one you want to use. Okay, so first I'm going to show you how you could use division to prove that 2 and 4 are in fact factors of 8 of 32. Okay, so first of all, I divided 32 by 2. I really didn't have to, because 32 is an even number, and I know that all even numbers are divisible by 2 with no remainder, but I went ahead and showed that. And then I know that 32 divided by 8 equals 4. So since I can divide 32 by 2, and I can divide 32 by 4 or 8, and I do not have a remainder, then that means that 2 and 4 are indeed factors of 32, just like 8. And then I use the associative property. So I showed that 32 equals 8 times 4, and then I decomposed 8 into 2 times 4. So 32 equals 2 times 4 times 4, and then I moved my parentheses. So now I'm showing that 32 equals 2 times 16. So if 8 times 4 is 32, then 4 is a factor of 32, and 8 is a factor of 32, and 2 and 16 are also factors of 32. Now remember, you did not have to use both of these strategies. It's always safe to divide. But if you think mathematically, you can save yourself some work if you look for patterns to figure out whether a number is a factor or not.